Hello, how are you? On this video, I need to configure EIGRP configuration. EIGRP is advanced distance vector routing protocol that is used on a computer network for automating routing decisions and configurations. And this protocol is only designed by Cisco Systems and is only available on Cisco routers, and it determines the value of the path using 5 metrics only, which is bandwidth, load, delay, reliability, and MTU. And it also uses 5 different packet types when communicating with its neighbors, which is hello, update, query, reply, and acknowledgement. You have to know also what makes this protocol different from other IGP matrix. Like the routing protocol like RIP, OSPF. This type of protocol, EIGRP, does not use a single attribute to determine the metric of its route. Like in a RIP, we use hop counts to determine the matrix. This means that all routers received from the same router will have the same matrix. This is regardless of what kinds of interface we receive that router from. The OSPF matrix is a bit more granular. Instead of hop count, the OSPF matrix is the sum of interface cost. The cost assigned to an interior the interface is an inverse function of the bandwidth of the interface. This seems to scale well since the routers received on interface with higher bandwidth are preferred to interfaces with lower bandwidth. What we have to do now here is we need to configure. I have done already the graphics and set these topologies with the different networks. Like the first network that I put on my left, on my left, that is 192.168.3, and the second one is 172.18.1, and the other one is 192.168.1, and the other one is 172.16.1. The other one is 192.168.2. So what we are going to do here is we are going to do the first configuration on this topologies, and when we have done that, we have to configure the EIGRP, this protocol for these networks to communicate together. So what we have to do here is let's just do configurations on all these networks. Okay, for this one, let me just do like this. I just want to edit here. I put welcome to CCNA lecture on configuration on EIGRP configuration. Okay, then let's just save this note. Okay, let's just start to configure. We can start anywhere. We can start here. This is 0 by 0, this is 0 by 1, this is 0 by 0. So what we have to do, we need to do a quick configuration on these networks. Let's just do a quick configuration. We can check first on it, then we put 172.18.1.1, subnet mask, then we put it on, then we go on serial 0 by 0, we put 10.0.0.1. Let's just do a quick configuration. Serial, this is 14.0.0.2. Put it on, then we are done here. Then we go to this one. This is 1 and this is 0. Let's just do it as quick as possible for us to go to what we need to go to. So we 192.168.3.1. This is up. We go to 10.0.0.2. I think this is 1. Okay. We go to 0 by 0, 11.0.0.1. Then we put it up. So we go to this one. Let's do it very quick. This is 0. This is 1. Okay. Let's just do it very fast. This is 0, which is 11.0.0.2. We put it up. Then we go to 1. This is 12. This is 12. I got it up. We go on Fascinate. 192.168.2.1. We put it up. We are done with this interface. So let's go to this one. This is 0. This is F0. This is F1. This is 1. So let's go on F. We 172.16.1.1. We put it on. We go on 0 by 0, 0 by 0, which is 12. 2. We put it on. We go to 13.1. We put it on. We go on. This is 1. This is fast internet 1. This is fast internet 2. 1, which is 15.0.1. Okay. We put it on. Then we go to this one. We have a fast internet. We have this one, which is 1. This is 0. So 0 is 0 is stating 2, which is stating 0.2. We put it on. We go to 1. 1 is 14. It's 14.0.0.1. We put it on. We go to fast internet. Fast internet is what this network is 19.1. 192.168.1.1. We put it up. Then now we are done with our configuration. So we just want to do quick configuration on our desktops, our PCs, which is 192.168.3.10, 192.168.1, 15.3.1 DNS server, which is 15.0.0.2. This is our DNS server. .2. We go here. This is this is 172.18.1.20, 172.18.1.1. Our DNS server 1.0.2. We are done here. Then we go here. Let's do this one, a quick one. 192.168.1.50 192.168.1.1. Our DNS server 15.0.0.2. 16 here. 172.16.1. 172.16.1.100. 172.16.1.1. Our server. Then the last one. The last one, 192.168.2. Oh, let's put the 10. 192.168.1.2.1 DNS server .z.z.1. We put 10 here. Let's amend here. Let's put it 10 here. So we are done with our configuration, so we can as well test the movement of our, it is successful. If we check here, let's just check the nearest router is working. Let's just check here. So this one we did not even configure it. This one is failing. So what we need to do here, we go here, we configure this one, 15.0.0.2, 15.0.0.1, 15.0.0.2. So we can as well test it, because let's just test it here. They are on the same router, so when they are on same router, they that's successful. They have to share information. So when you are testing here, it is failing because it is not. They don't share the same network, so they are on this different network. So what we need to do here, we need to put EIGRP so that these networks can communicate very well. You see, as you know that EIGRP is a unique routing protocol because it seems to combine the great features of both distance vector and the link state routing protocol. So what we need to do here is to configure it. So let's go to this, we're going to go to this router. So sometimes the routing protocol can be, let's say, will be like configured by default. So now what we need to do is to remove it. No IP routing. We need to remove some of the default routing protocols. So now what we need to do here is to say no IP routing, then IP routing, then router EIGRP. Then you can check the range. The range is from 1 to, if you check here, it's from 1 to 65535. So what we need to do here, we can choose any. We can choose, let's choose 100. Let's choose just 100. Let's choose 100. We choose 100. So network, let's put 192.168.3.0. So what we have to do is this is class C. So you put 0.0.0.0.0.255. So enter. We go to class A, which is 10.0.0.0. So what you have to do is .255.255.255. So we go to another class 1, which is 11.0.0.0, which is 0.255.255.255. So we are done with this one. We write end here. We write end. Then what we will do is show IP root. We show IP root. So you see our root is these are the roots that we have. This is directly connected. This is directly connected. This is directly connected. All these three networks are directly connected to that router. So you go to the next. Let's just take this one. Configure, enable, config T, no IP routing, IP routing, root EIGRP. We put 100 here. So we put networks. So let's start with 192.168.2.0, which is 0.0.0.255. We go on this one. Let's take 11.0.0.0, which is 0.0.0.255.255. Neighbor, network. We go to 12.0.0.0, 0.255.255.255. We are done with it. We put end, then show IP root. We just want to see the root here. You see, we now have 10, 11, 10.0, 11.0, 12.0, 192.68.2, and 192.168.3. So what we need to do here, we go to the next one. Let's go to this one, this root. Enable, config T, no IP routing, root EIGRP 100 here. Then we take network. Okay, we start 172.16.1.0, which is .0.0.255.255. We have network. This is 16. We go to 12.0.0.0, which is .0.255.255.255. This is neighbor. This is network. which is this is 12. We go to 13.0.0.0, which is .255.255.255. We go to network, which is another 15.0.0.0, 255.255.255. We are done with this one. We have 12, we have 13, we have 15. So end. Then show IP root. Then we show IP root. We have 10.0, 11.0, 12.0, 13.0, 15.0, 172.16, 192.168.2, 192.168.3. So we are going. Let's go to this one. We just want to finish very fast. Enable config no IP routing, IP routing, root EIGRP 100, network here we have 192.168.1.0. Okay, we go back here, we get to dot 1.255. Marker network invalid marker. We have 255 192.168. We have here .0.255. Here it's okay. Then we go to network. We go to 13.0.0.0, 255.255.255. Neighbor. Then we go to, which one is this one? This one is 14. Network 14.0.0.0, 0.255.255.255. And show IP root. We have 10, 11, 12, 13, 14, 15. 172.16, 192.168.1.2 and .3. So now we are going to this one, the last one. Let's just configure the last one. Let's just okay, enable config no IP routing, root EIGRP 100 here. Network, they share the same autonomous, they share the same number. We don't change. If you change it, sometimes it will be like tricky. You don't change, you just give one number. Just is what I've done here. I just put 100. All the routers just put one number. Okay, just put one number. So we take this one, which is network, which is 172.18.1.0 0.0.255.255. Network, we go to 10.0.0.0, which is 0.255.255.255. okay, this is the neighbor. We go to, we need 14. Network 14.0.0.0, 0.255.255.255. This is neighbor again. So so what we need to do is here put end here, then show IP root. You see here we have 10, 11, 12, 13, 14.0, 15.0, 172.16.0, 18, and 168.1.2.3. All the routes are covered right now. They are covered. You see, D, which means it's directly connected. That is D. That is D. That's what we have here. Is directly C is directly connected. D is linking. That's our EIGRP. Okay, this is the area. This is the external one. That's D. C is directly connected. That is connecting to the interface. Okay, so we are done. So what we need to do here, is now checking whether these networks are now sharing information. They were failing, so now if you check here, are successful. If you check this side from this end to this end, it's let's check here. Let's just do this. Enable show IP route. We have 168.2 is there. So what you have to do is to check the IP address here. Is 3, the gateway is 3.1, which is this is correct. Then this one we have also checked. This is 2.10, the gateway 2.1. So if you check here, let's check our web browser, which is 15.0.0.2, which is our web browser, which means we are connecting. Welcome to CCNA lecture on EIGRP configuration. So which means you can also check with this, you can ping. Let's try to ping this area. Maybe let's try to ping this area. You see, these networks are communicating, so we have to ping again this area 192.168.2.10. check this one. These networks are communicating, so we can as well check our with this one. You see, welcome to CCNA lecture, which means our web browser, we are browsing. Also, we are pinging the whole areas. Every area we are pinging. There is communication within these networks. There is communication within these networks. If you check, there is communication within these networks. If you can as well. This one is let me try this one. This one 15.0.0.2. Let me try this one. You see, it is connecting again. There is communication within our networks. There is communication within our networks. We are done with our configuration of EIGRP, its protocol. We are done with it. This is enhanced interior gateway routing protocol. This is an advanced distance vector routing protocol that is used on a computer network for automating routing decisions and configuration. Even if you remove this one, let's say you want this network is disconnected. Let's say this network is disconnected. Let's say this network is disconnected. right? We need these pieces like this area to communicate with our server here. You can go to this PC and check the server, check our server. If you check here, it is really communicating. No matter you have disconnected, this part is disconnected. If you check here, serial 0x1 is down, interface is down. Okay, let's say you want to put it up. Let's say you put it up, like you put it up again, you put it up. Then if you check here, change state to up, it was down, but it's now up. So the communication will continue no matter one part is down, no matter one network is down, one router is down. So the communication will continue, the people will continue working. You save the downtime of the network with this protocol again. So this protocol is very important to our organizations. So we need to play around with this protocol, use it in our organizations, and also this is very important to those who are doing like CCNA, so they have chance to go through this. If you can check here, this is the whole area is connected, is linked, so it's easy to communicate using this area and this area and this area and this server. Also we can, okay, if let's say we have also, I'm going to put another video for HTTP server, another server. How many DNS server do we need in an organization to maintain our uptime of our internet, of our network? So because sometimes when we are experiencing a network more downtime, you have to add 2 or 3 DNS, because those, and you have to set it like those 2 DNS will replicate the information, so that when one DNS server is down, the other DNS server will serve the same purpose, because they have the same information. The information has been replicated, will be replicated in all the servers. So when one server is down, the other server will take over. So I'm going to do the other video concerning that those servers. So thank you very much for watching this configuration of EIGRP. Enjoy the video, subscribe if you like the video, comment, pass your comments so that I can read and give you more videos. Thank you.